With the shuttle launch control, we're at T-minus 3 hours holding. We have joined the flight crew for the 41-D mission in their quarters in the operations and checkout building, now having breakfast. Going from left to right, as far as this crew is concerned, is Steve Hawley, one of the mission specialists, Mike Coates, who is the pilot, payload specialist Charlie Walker, and then Commander Hank Hartsfield, Judy Resnick, and Mike Mullane, who is another of the mission specialists on this particular flight. Mike Mullane will be MS-1, and Judy Resnick is the third member of the mission specialist team on this particular flight. Hank Hartsfield will be making his second flight on this particular mission. He was a pilot on the shuttle's fourth flight aboard Columbia, which was also the last of the shuttle test flight. Judy Resnick will become America's second woman in space. She'll be responsible for extending the 102-foot solar wing that is part of the OST-1 package that's tucked away in Discovery's payload bay. She'll also operate the Canadian-built robot arm, which should provide some spectacular color television pictures from its elbow camera. Back in the firing room, things are very quiet. The closeout crew continuing their work in the crew module in the white room to get Discovery ready for the flight crew's arrival, which should occur about an hour and 30 minutes from now. And here is the flight crew for 41-D, led by pilot Mike Coates, going down the hallway that will take them to an elevator, which will take them down to the ground floor of the operations and checkout building. Accompanying the crew, Director of Flight Operations George Abbey, Head of the Astronaut Office John Young, who will also be the weather pilot this morning. There's also a group of news media representatives at the OST building to photograph the crew as they leave their quarters and prepare to take the trip to the launch pad. Commander Hank Hartsfield leading his crew out of the operations and checkout building, joined by Steve Hawley, pilot Mike Coates, Mike Mullane, Judy Resnick, and trailing the group is payload specialist Charlie Walker. NASA security specialist Gary Fuchs closing the door to the astronaut van as they prepare to bring the flight crew to the launch pad. The NASA test director has asked safety to notify him when all the non-essential personnel have left the launch danger area roadblock, and the closeout crew has completed their work in the white room. They should be leaving the pad very shortly. As they depart the pad, they will configure the elevators for launch. Flight crew has been performing another in a series of voice checks with Mission Control on the air-to-ground network, and as part of this test, Houston updates the crew on the latest altimeter settings and runways to use in the event of a return to launch site abort into KSC or the transatlantic abort to the airport at Dakar, Senegal.
And this is Mission Control, Houston. Ascent Flight Director Gary Cohen has pulled the controllers here in the Mission Control room, and all positions have given a go for launch. This is Mission Control. Go ahead.
Coming up on the hold at the T-minus 9-minute mark. T-minus 38, repositioning orbiter vent doors, coming up on a go from ground computers to start the onboard ground. T-minus 31 seconds, we have a go for auto sequence start. Discovery's 4 computers now have primary control of critical vehicle functions. T-minus 20 seconds and counting. T-minus 15. T-minus 11. 10. We have a go for main engine start. 6. We have main engine start. 3, 2, 1. We have SRB ignition and we have liftoff. Liftoff of mission 41-D, the first flight of the orbiter Discovery, and the shuttle has cleared the tower.
Mission control confirms roll maneuver. Standing by to throttle down to 65%. Again, passing through the period of maximum aerodynamic pressure. Throttling down at a 2 step section, first 84%, then 65%. Throttling down, confirmed, 45 seconds. Altitude 3.5 nautical miles, downrange distance 2 nautical miles, velocity 2150 feet per second. Passing through the period of maximum aerodynamic pressure. Engines running at 65%, velocity 2400 feet per second. Engines throttling back up. Throttling to 104%. Discovery given go at throttle up 1 minute 30 seconds, velocity 3400 feet per second, altitude 13 nautical miles, downrange distance 8 nautical miles. 25 seconds away from SRB staging. Three engines running at 104%, velocity 4600 feet per second, altitude 20 nautical miles, downrange distance 15 miles. Standing by for SRB separation. Crew reports PC less than 15. SRB separating. SRB confirmed, velocity 5200 feet per second. Guidance conversion is programmed. Altitude 30 nautical miles, downrange distance 30 nautical miles. Discovery Houston, first stage performance, nominal. Discovery Houston, single engine first major. At that call, Discovery can continue on to main engine cutoff on only a single functioning engine if necessary. Velocity now 20,000 feet per second, altitude 59 nautical miles, downrange distance 515 nautical miles. Three engines continue to function normally at 104%. Three engines now throttling back to for the passing through the period of 3 Gs. Velocity 22,000 feet per second, altitude 58 nautical miles, downrange distance 600 nautical miles.
Have a good meet, John.
Roger that.
And this is Mission Control, Houston.
Discovery Houston with you through Hawaii, and we've got a good picture of you all in the crew module.
Discovery, roger. Okay, Dick, you ought to have a picture of the SPS spinning in its cradle there.
Discovery Houston, that's what we're looking at, Steve.
Okay, tell you what, the deploy was just absolutely as normal as could be. The equipment worked completely perfectly, and procedures are in good shape, and everything worked real good. It was nice and easy. And in a second there, you'll see the deploy, and we felt the bang and the orbiter shudder a little bit, as I remember, I think John Fabian told me from STS-7. And right after deploy, we swapped over to Spec 62 and looked at the PDI data, and we seem to be locked up right away and for quite a distance with the PDI data, the telemetry from the PAM vehicle.
We copy, Steve, and we think the problem that we had down here was the problem we had on the ground. The orbiter looks good. Additionally, some more info for you. We had a successful separation from the spacecraft from the CKM, and spacecraft from all available data and tracking looks like it's happily on its way to apogee.
Okay, that's wonderful news. We're glad to hear that. And Dick, you should see the ignition just above the end effector in the lower part of the picture if you're looking at the downlink of the wrist camera right now.
Okay, we just got a glow, which yeah, okay, we've got it real good now, Steve. Discovery Houston, 1 minute to LOS Hawaii. We'll see you at TDRS at 2-8. We're going to be powering down the PI and PSP. You can ignore your message.
Okay, Dick.
And that was a great bit of footage there, Steve. It's obvious that you were right with the payloads people and seeing that good burn.
I know we're about as happy as they are. Everything worked just right.
This is Mission Control. We have the downlink television of the pre-deploy activities. We're 29 minutes away from the deployment of the CENTCOM. We have cabin television again. The payloads people have said that we're go for deploy.
Okay, John.
Spacecraft passing over the Houston area at the present time. They can observe.
Become a good weatherman.
Roger that. And we have a note for Mike. Donna says that all the ducks are in a row.
Okay, thank you.
Okay, we've got it now, Mike. Looks great.
Okay, pulling the pins was completely nominal. We did, well, there it comes out now, you can see. Heard a little bit of a thump when it deployed. The Omni antenna was extended in about 20 or 30 seconds. I mean, that's how long it took to extend. It was a beautiful sight, seeing it against the background of the Earth.
We concur with that.
Yeah. I guess it proves the physics of frisbees works up here as well as it does on the ground.
Roger that, just like in the SMS, and thanks goes to the camera person.
Okay, JR, I'll take that compliment. And just as we have been practicing in the SMS, we were able to track it all the way through the Ohmsburn. At the Ohmsburn, the CENTCOM was in front and above us relative to the orbiter, and we were easily able to track it.
And this is Mission Control, status check in the control room here. All positions are go for deploy. This is Mission Control, 2 days, 0 hours, 26 minutes. We're looking at the sun shields in the cargo bay. 16 and a half minutes away from deployment. Crew beginning mechanical sequence start. We see mechanical sequence beginning and the opening of the sun shield on the Telstar. Payloads reports the nominal 2-motor current drive. Starboard restraints on the spin table are being withdrawn. And very shortly we should see the spin up again of the satellite.
And just like STS, it all worked super good. It was absolutely nominal.
That really looks super.
Yeah, we don't get to see it in color. We only have black and white TVs. I don't know if Mike mentioned it to you yesterday. When we deployed the CENTCOM, we felt just a little bit of thud when it left. The Telstar felt like the SBS did the other day, and that was a little bit of a jolt.
Roger, copy that, Steve.
John, I'll let you watch this as long as you want, and then I'll switch over to the PKM burn.
Okay, I'll give you a call.
Okay, John, just for you, we have configured the arm, and I'll see if you can figure out what this is here.
This is a test.
Roger, it's a nice 41-D.
D for Discovery.
Roger that.
Now we're trying to show you the PLT, but he's kind of dark.
We're glad you're doing that. Steve, he looks so good, we were about to ask you to do.
John, as you can see, Mike decided he was going to take over. He's now the commander and Henry's the pilot.
Roger, we were wondering if they were going to do entry that way.
In the foreground here we have Mission Specialist Mike Mullane. It's up the aft flight deck. And also Judy Resnick, also at the aft flight deck. This is mission control. Today's 2 hours, 13 minutes mission elapsed time. Television from orbit through the KU band of the tracking data relay satellite. The shuttle is on orbit 34, running parallel to the northeast coast of South America, just off over into the Atlantic. Standing by for the 2-engine ohms burn to recircularize the orbit. About a minute and a half away. Fortunately, we may be able to see the ohms engine light on in about a minute. We're 30 seconds away from the ignition of the ohms engines. Previous shuttle astronauts have indicated that normally you just see a momentary flash as the engines light off. Normally you would not see the full burn of the engines. 3 seconds. And then we had the flash as the ohms engines ignited. And the burn is in progress. Propulsion's officer reports that the burn looks good.
This is Huntsville Operations. We are currently receiving live downlink television from the spacecraft, and we anticipate here shortly to be able to see from this view the extension of the solar array wing. During this extension, it will be extended to approximately 73 feet, about 70% of its full 10-story capability. This being the first extension of the wing during this mission, and this particular extension, and which will be followed by, within about 10 minutes, by a retraction. It is designed to gather data on how the wing extends and retracts. And now visible in the field of view, on the left of the field of view, is the solar array as it is slowly extended at approximately 1.5 inches per second. The dark area is the folded array blanket panels, Kapton panels. They unfold in an accordion fashion. And near the top of the field of view is the tip of the extension mast. In the field of view, 2 white circles, which are targets used by the cameras mounted in the cargo bay during future tests, when the array will be excited by the firing of the reaction control system. These circular targets are designed to provide the capability to actually document the motion and measure the dynamics of the array wing.
Discovery Houston, handing over to Tidris.
Discovery, roger.
The array is fully extended to 70% of its length, or about 73 feet. And the crew shortly will begin to pull it back down. They reported that it took 9 minutes, 19 seconds to deploy it, which folks here on the ground agree is a good time.
We've got television back, and it looks up and big.
Roger that, Dick.
This is Mission Control Houston. We're seeing South America now as orbiter Discovery passes along the coast. It looks to be the southern Andes. And again, this is live payload bay television through the tracking data relay satellite. We're looking from the elbow camera on the remote manipulator arm.
And Discovery Houston, we've got a real pretty picture of the Earth.
Okay, Dick, that's good to hear. The array is just a brilliant gold.
Okay, we're not seeing it that way right now, but we're more seeing it in black and white, Mike.
The trouble must be with your set.
We have a beautiful picture now. It's coming through.
Okay. We just had a beautiful shot of the Cape out the quarter panel window, but we couldn't get the camera over there in time.
Roger, understand. We were hoping you could do that, Mike.
And Houston, we have the camera looking out the window now, and you can see the shadow of the tail and the ohms pods coming through the array from the tail sun attitude.
Roger that. That's a real beautiful picture. Everybody's really pleased with that.
So are we. We're moving it back to the overhead window, and you can see probably how we've been describing that the array is bent a little bit further aft in the middle. I think you could probably tell that from the TV.
Roger, we can see it real clearly.
demonstrate the dynamics of the Frisbee deploy. We'll give you some traditional horizontal Frisbee here, followed by the CENTCOM procedure.
That's really great, Mike.
Okay, here comes the second CENTCOM to be deployed. That's about how the real one looked. A little bit faster, maybe.
Roger that.
Of course, the point is that physics works exactly like they told us it was supposed to, although sometimes it's hard to believe that a little bit of tangential impulse gets translated into translation and rotation about the center mass, and we just wanted to demonstrate that it really works.
That was a good demonstration, Steve. Can we see Charlie?
Of course, all this is probably interfering with Charlie trying to do his work.
We noticed that. That's why we asked if we could see something.
Well, I'm hard at work, calibrating the sample flow rate, making sure we're still on our desired target there. We've got streams flowing in the separation column. We've got a camera up to document the process. Got paperwork all over the place, trying to keep myself straight. We're just pressing on here in good shape.
Discovery Houston, that's a pretty good view you're showing us here. We're done with that. We would like to get the VTR dumped in of what you feel is significant of the last wastewater dump.
Okay, Dick, gets on its way.
This is Mission Control. We're looking at videotape of a wastewater tank dump.
Discovery Houston, it looks like we're getting the VTR now, and we'll have a state vector coming on board.
Roger.
This video was taken earlier when the crew was attempting to deplete some of the water in the wastewater quantity tank. The large odd-shaped ice structure is coming out of the water supply tank valve. Beneath that, the dark opening is the wastewater tank valve, and forward of that is the vacuum vent opening. This is on the port side of the orbiter. And we see the ice growing out of the wastewater tank valve.
Spectacular.
Yeah, that's what we thought too. Okay, Dick, we got TV coming down now on the Cephas. Can you get it?
Well, maybe in a few seconds. Right now we're still watching Judy. Okay, we've got you now, Charlie.
Very good. What you're looking at here is Discovery's first payload specialist operating industry's first preliminary production device in space. There's one little operation I need to do on the thing to ensure that the sample delivery pump is operating up to speed at all times. And right here, you can see me doing that. I'm timing the operation of the delivery of the material, taking notes, as all good quality control people do, and
Believe me, in that orientation, it looks a little odd, but it's a lot of fun up here in 0G.
Discovery, Houston, could we get TV control to command?
Now, also, what I end up doing is, upon separation of the material in this device, which again is separating biological substances that we hope to produce for physicians to treat illnesses and maladies on Earth that haven't been treatable before. One of the things that I've been doing is sampling that purified material that the machine is turning out, and part of that sampling operation is to determine the goodness of the product which we're turning out. You can see that the operation is a little awkward, maybe. It looks a little awkward, but it's again, a lot of fun, and it's easier to do in some ways up here than it is on the ground, taking a small amount of sample out of the device and applying it to a kit form that will tell me if the purified product is where I want it to be or not. And so far, it's been there. Now let me fast forward again a little bit here for you.
Charlie, it sounds like you're ready to become plant manager of the production unit.
Now at the electronics module, there in front of me in the picture, I control the device, control its operation, and through that can influence the goodness of the material and the quality of the process. Now here you'll see a kind of a guided tour. That's the separation chamber itself, where the separation of the substance takes place using an electric field. I'm pointing at the electronics module in the locker face in the mid-deck here of the orbiter. And the bottom of the large fluids module, there is the delivery pump that pumps the purified material, or the raw material, unpurified, up through the separation column, where it is purified again using an electric field and continuous flow of fluid. And at the top of the module there, you'll see the collection area where I have drawn out samples previously and for the testing, and where we collect it for final return to the ground. The device has been in operation since flight day 2. There have been some equipment problems with it, but nothing really that I haven't been prepared to do on the ground or from previous ground preparation. All right, I think that about completes our guided tour.
Discovery, Houston.
Hi there.
Hi, JR. Before Henry starts the RMS procedure coming up at sunrise, there are probably a couple things that I ought to tell you, particularly about clearances and camera views.
Okay, we're listening.
Okay. You've taken a look at the elbow camera, so you know that you can see the wrist now and you can see the clearances. When you get into the position in single from which you're going to translate in orbiter X, you're going to be probably only about 5 inches from the orbiter skin, the port side of the orbiter, and you're going to keep that 5-inch clearance as you translate.
Okay.
You're probably going to be just a little over a foot above the root of the wing, and you're going to keep that foot clearance as you translate an X.
Okay, we understand that.
Okay, and as you start the X translation, you're initially going to be able to see the orbiter and the ice. but as you move closer, you're going to eventually lose sight of the ice. Probably you'll lose sight of it about 2 feet away from it, and that's just because the camera is positioned about 20 inches above the point of resolution, so the camera will be looking over the ice as you get close to it.
Okay, that makes sense.
Yeah, and of course the important thing there is not to try and fly it down to keep the ice in view, because that'll get you real close to the wing.
Right.
And I guess the only other thing, which is probably going to be obvious to you from your elbow camera when you take a look at it, you can check the clearance from the door as you start from the elbow camera, but you're going to lose sight of the end effector going under the door. That dump port is about 4 feet under the wing, so you're not going to be able to see the arm from about the wrist yaw joint on. It's going to be under the doors.
Okay, I'm sitting up in Henry's seat, and I can see a little bit out the window. I'm not sure how much I'll be able to see of that.
That may be the best view of it. That and the side hatch window, you may be able to see something too.
Okay.
That's about all I've got.
Okay. We'll let you know how it works.
Okay. Sorry you have to try this.
And the mission commander, Hank Hartsfield, controlling the end effector, and now beginning very slow progress toward the crystal. The camera's mounted about 2 feet above the end effector, so there won't be any visible evidence of the contact of the end effector with the crystal.
Discovery for Sally.
Go ahead.
The minus 2625 constrained in X, is that the clearance between the lower boom and the door? What I mean to say is that to keep a sufficient clearance between those two?
That's correct.
Okay.
And I think that gives you about 15 inches clearance, but I'm not positive of that number.
Okay, I can see that clearly out the window.
We have contact, and there are minor particles visible flying off the screen. Camera backing away now to assess the effect. Well, as is obvious from the picture, the procedure was successful.
This is George Bush. Can you hear me okay?
Yes, sir. Loud and clear.
Well, we're delighted to be here in the center, and my wife Barbara's with me, and we're watching you in a pink-looking pink Panther airplane going across this big center board here, and it's absolutely fantastic. But more important, how's it all going up there?
Well, it's going extremely well, Mr. Vice President. We've had a pretty exciting mission. I think we've got most of our objectives accomplished, and we're getting ready to button it up and bring it home. We've got a fine addition to the fleet of orbiters. We'll bring him back with us.
That's good. It's read well from down here, and ever since you got your plumbing problems fixed, too. That's very good. How's Judy doing? JR?
Oh, I'm doing just fine. We've been having a good time up here, working together as a team and trying to get all of our deploys and tests done, and also having a good time in the meantime.
When are you going to come home?
Well, tomorrow, probably.
We'll be waiting.
Well, say hello to all the rest, and I don't want to keep you because I know what you need is one more interview, but we're really proud of you, and I just wanted to have this opportunity when I'm back in my own hometown here to say hello and congratulate all of you. We're proud of you, and it's a great inspiration, and I expect you would agree that a lot of people down here are helping out, too.
Oh, we certainly do. We appreciate you taking time to come over and talk with us, and you're absolutely right about getting help from down there. We're just a tip of a little iceberg of a great number of people. One of our former guys said once that we stand on the shoulders of giants, and I think that's true.
You call John Young a giant? He's standing right here, so be careful what you say. Okay, well, thank you all, and God bless you, and best of luck to you. It's just we're very, very proud, and thanks for this chance to just cut in and say hello. Back to bed now.
Thank you, sir.
Orbiters encountered a hack making a left-hand turn. Continues on course on time, 15 miles from the end of the runway, altitude 23,000 feet, touchdown in about 2.5 minutes.
Discovery, Houston, your nav is good. You're about 3,000 feet low.
Discovery, roger.
A NASA T-38 being piloted by Charlie Justice from Aircraft Operations in Houston, rendezvousing with the orbiter. That T-38 carrying an IMAX camera. Sync rate is 130 feet per second, range 10 miles. Mach 0.5 velocity, 16,000 feet altitude. Touchdown in roughly a minute and a half. The flight control system still in the auto mode. And making a perfect left turn right around the heading alignment circle, 8 miles from the end of the runway. Approximately a minute from touchdown, 13,000 feet altitude. Ship is now converging in the glide slope coming off the heading alignment circle, lining up with runway 23 at Edwards. Runway 17 at Edwards. 6 miles from the end of the runway, about 30 seconds from touchdown. Altitude 7,000 feet. Sync rate a little under 200 feet.
Houston, you look good on final.
Roger, thank you, John.
Energy look very good. Altitude 5,000 feet, 4 miles from the end of the runway. Altitude 3,500. Range 3 miles. Altitude 2,000 feet. Range 12,000 feet. Gears down. Altitude 300 feet. Just 800 feet from the end of the runway. And the main gear are down. Nose gear is securely down. A touchdown at a mission elapsed time of 6 days, 56 minutes, 4 seconds. Nose gear down at 6 days, 56 minutes, 16 seconds.
London and we'll stop. Welcome home. Here, first down the ladder, it's Mission Commander Nick Kirkby, followed by Pilot Mike Coates, Mission Specialist Mike Mullane, Steve Hawley, Judy Resnick, and Payload Specialist Charlie Walker. Being greeted by George Abbey, Director of Flight Crew Operations for Johnson Space Center, Houston, and the crew making an inspection of their ship after 2.17 million miles of time in space.
Ammonia area off now, Houston.